Hi, yeah. In this video, I want to show you how to perform one-way ANOVA analysis on a somewhat real data set. So first, let's read in the data using red.csv. So this will be a subset of the Framingham study data set with 1,000 subjects in it. So of course, we can using the structure function, just take a look about the variables in this object. We noticed many variables. They're categorical, they're continuous variables, but it seems like for the categorical variables, we only got the 0, 1, 1 or 2. There are only two categories. So we cannot really do a ANOVA analysis, right? So that's why I want to create a categorical variable with 3 or more levels. So I choose the BMI variable. So first let's calculate the summary statistics. You can see it's the minimum, the median, the mean, the maximum, and there are two missing values. Okay. And I searched online and found these cutoff values to define underweight, normal weight, overweight, moderate obesity, severe obesity, and very severe obesity, at these cutoff values. And then I use the function cut to cut the continuous variable BMI into these categories. So you can see the cut parentheses, then df BMI1, that's the original continuous variable, and you get the breaks, those are the cut values, and then the labels, those are the labels for each category. Okay. So let me execute this chunk of code. And now the BMI categorical, BMI cat variable is created. It looked like this. It has 6 categories. Seems they have the values of letters. But fortunately, that doesn't matter. They don't have to be numeric. We can just analyze them directly. For example, we can use the table function to take a look at the frequencies in each category. Okay, and then we can use the AOV function to do a one-way ANOVA analysis to look at the systolic blood pressure in these different BMI categories or weight categories. So we can use AOV and we save all the output into fit.aov. And then we can summarize it. So this is the ANOVA table, and the p-value is very, very small. That tells us we have to reject the null hypothesis of equal means. So there are some significant differences of the blood pressure level across these weight categories. Okay. So the next step is to figure out exactly which groups have different blood pressure levels. For doing that, we can use the two-key HSD function, and we specify order equal to true. And this will print out the result of this two keys test. You can see it's arranged from the underweight to normal weight to overweight and different obesity levels in that order. And then the last column is just the p-value. And if you read them carefully, you can see there are differences between all the obesity categories and an underweight and the normal weight. And then there's differences between very severe obesity and moderate obesity, but there's no difference between very severe obesity and severe obesity. And there's no difference between severe obesity and moderate obesity. Okay. So this actually tells us we may be able to collect some categories because some are like really like obesity categories are different from any of the weight, like underweight, normal weight, overweight categories. Okay, so but for demonstration purposes, we have 6 categories. I just want to go through this so that you get a sense about how this multiple the post hoc test is done. Okay, and again, if you want something visual, you can use the plot function to plot out. You can see on the right, there's a vertical line at 0. So any of the confidence intervals that does not contain this 0, those are the significant differences. Okay. All right. Hope this is helpful, and thank you for watching.